Hey everyone, welcome back to my channel. This video is going to be the first in a new series I created where I explain different data structures and algorithms and how we can use them in Python. Now, although algorithms may seem a little complicated, I'm here to make them easy and simple for you. Now, today's video is going to be about binary search. Binary search is a very common algorithm, and it's often used to search a certain element in a sorted list. So, for example, here we have a function named search, and we take in two arguments. Nums, that's going to be the list of numbers, and target, which is going to be the number that we're searching for. So, for example, if we have this list over here, 1, 2, 3, 4, 5, 6, 7, which is a sorted list going from the lowest number to the highest. Here we're going to search for a certain number, and then we're going to return its index. So, and to do that, we're going to implement a binary search in Python. Now, we're going to begin here by setting two variables, lower and upper. Now, before we get too deep into this, I do want to explain what binary search is and how it works. So in binary search, essentially, we're going to divide this list into two parts. The first part and the second part. And we're going to search if we're going to see the number that we're trying to find, if it's in the first part, or if it's in the second part, or if it's the middle number, right? And let's say we know that it's in the first part, okay? We've determined that the number is somewhere in the first part. Then we take the first half. Then we take the first half and we divide it into another half, and then we see, and then we repeat this process until we find the number, the specific number that we're looking for. So here we're gonna define the minimum, or like the bottom lower number, and that's gonna be 0. And the upper number is gonna be the length of our list minus 1. So for example, if we have a list of 7 numbers here, the upper limit is gonna be 6, and the lower limit is gonna be 0. So now from 0 to 6, we're gonna search if our number is anywhere in between that, and we're gonna keep slicing the list in half until we find the index of the number. So in the while loop, which is basically keeps this code running, we're gonna write while lower is less than or equal to upper. This way, this just makes sure that the program is valid, because if the lower variable turns out to be higher than upper, that means that the number that we're trying to find is not actually in the list, and in that case, we're just going to return none. But if assuming that the number is in the sorted list somewhere, we're going to run basically this control flow. Here, we're going to define a variable called mid, and mid is going to be like the middle number in the list, and that number, the mid, is always gonna keep changing depending on which iteration we're on. Now in the first iteration, mid equals to lower plus upper, and then floor division by 2. So here, lower plus upper is gonna be 0. It's gonna be 0 plus 6, and then divided by 2, and that's gonna be 3. So our middle number for the first iteration is gonna be 3. Now, if nums 3, so if the third index of our list, if that's equal to the target here, and the target here in this example that we're using is going to be 5. We're trying to find the index of the number 5 in this list. So if this certain index is equal to 5, then we return mid. But since the third index of nums, which is 4, since 4 is not equal to 5, we're gonna ignore this and move on to the next statement. Else if nums mid is less than target. So if and then nums 3 is less than 5. Now again, the third index of numbers of this list, the third index is 4, and so since 4 is less than 5, since it is less than the target, we know that the mystery number, the position of this number is somewhere in this range, okay? And we know that because we've kind of eliminated all of these as options that are valid, and so we know that 5 is somewhere in this range. We just have to find its index and return it. Okay, so now what we're gonna do in order to keep that going is we're gonna set lower to equal to mid plus 1. So since mid mid is 3, so lower is now gonna equal to, let me just write that down as a comment. Lower is gonna equal to 4 because 4 is 3 plus 1. So now we're gonna run this iteration again, and this time mid is gonna be lower plus upper. But since lower is 4 this time, it's gonna be 4 plus 6, floor division by 2, and then here we're gonna end up with 5. So the middle number is actually gonna be 5, and if nums, and then the fifth index, if that's equal to 5. So the fifth index of nums here is 6, and 6 is not equal to 5, and it's not less than 5 either. But instead, 6 is actually greater than our target number, which is 5. So now we're gonna set upper to equal to mid minus 1. So since mid over here is 5, upper is gonna be equal to 4. So now, as you might have noticed, lower and upper are both 4. So that way, in the next iteration, in the third iteration, we're really limited to just the 4th index. So now, after after both of these iterations, we know that the target number is in the 4th index, right over here. Okay, and the reason we know that is because if nums mid is equal to target, so if nums 4, since mid is gonna be 4 over here because 4 plus 4 divided by 2 is 4. So yeah, so if nums 4 is equal to 5, which it is, then we're gonna return mid, which is 4. So in the end, when we run this, as you can see, the result is 4 because that's the index of our target number. Now if we change the target number to be something like 3, and then if we run the program again, then we know that the index is 2. So binary search is actually a really good way to search a sorted list, because no matter the length of the list, it's gonna be like the most effective method. So that was it for this video. I hope you liked it. I hope you like this new series. I hope you're looking forward to it. So don't forget to smash that like button, subscribe to my channel, and share this video with your friends.